Hi friends, welcome to follow up. In this video, we are going to explain problem 442. Find all duplicates in an array. This problem actually is very interesting, and sometimes you might feel tricky. But it's important to understand the assumptions of the problem. So let's first quickly go over the assumptions, then we'll explain the algorithm, and then do the coding and give you a walkthrough. So here we are given an integer array called nums of length n, where all the integers of nums are in the range given by the closed interval 1 and n. And each integer appears either once or twice. So this is a very important assumption, right? And also here in the range. So we want to return an array of all the integers that appears twice. So this problem, if you just read this paragraph, is rather straightforward. And basically you can count the unique elements and their frequencies, right? Then you can use list comprehension to get the unique elements that appear twice. That's it. However, we must write an algorithm that runs in ON time, in other words, linear time, and uses only constant extra space. So that's the point of the problem. This problem is very, very specific or very special for this requirement, especially, in order to require this this constraint, they have been assumed that the range, right? The numbers are in the range given by 1 to n. So a direct consequence of this assumption is that, so because the length of the array is n, so the index are in between 0 and n minus 1. In other words, the elements minus 1 will correspond to indices, right? So we actually can use the element minus 1 as the indices. That's basically the point of this problem. So here you can see there are 3 examples. Example 3 is very special because it has no element which appears twice. So we return an empty list. For the example 2, 1 appears twice. So we return an array containing the element 1. So in the first example, it's sort of the generic case. 2 and 3 appears both appear twice respectively, so we return 2 and 3. So the constraints are the following. First, the length can be as long as 10 to the power 5, and the elements are in this range. This is very important, and each element appears exactly once or twice, right? So with that said, basically we are ready to analyze the problem. I'll quickly explain the main point, and then we are going to do the coding, and after that we can walk through this example 1. I guess in order to explain some tricky things, a best choice is to walk through a generic example. So overall the approach will be use index to indicate a number appeared, right? So here I'm going to use this use number nums x minus 1. More precisely, I will say I use absolute value because I want to do negations in the linear scan. So I want to use this one, absolute value of x minus 1. So if the element at this index is less than 0, which indicates that absolute value of x appeared, right? So that's our main point. So what we want to do is that for carrying out the algorithm, so this is the algorithm, we are going to first initialize an empty vector, it's called answer or list, to store the duplicates. Then we are going to iterate through the array. So for each number, so here let's see, call this one x, and then we are going to consider its absolute value. Let's see, absolute value x, and then I want to check if this one is negative. In other words, if at a certain index it corresponds to a negative number, it means that index plus 1 has appeared, right? So here, check this one. If this, it means if absolute value of x is a duplicate, so we add to the answer. And also we want to mark this number as negative. So then we just return. So here we use absolute value because in between we are going to do some negation operations. So that's the algorithm. With that said, I hope that you have grasped the main idea. Let's first do the coding for this problem, and then we walk through one example so that you can get a deep understanding. So here I can initialize a list called result, and then I'm going to say iterate over this list. For y, let's use x. For x, so in nums, because in nums is a list which is mutable, and in the loop we are going to modify some of the element. In other words, we are going to consider absolute value of x. So let's see, x, let's use absolute value of x. So this will make x always positive when we do the check. Then we want to check if nums at this index x minus 1, if this is negative. If this negative, as we introduced here, so this number is negative to indicate this absolute value appeared. So if this appeared, so we are going to do result append x, right? So otherwise, so we just need to do negation. So you can put it in otherwise, because this already appeared, you don't need to do negation. But here, let's do, as long as we saw this, we are going to do negation. So we're going to do nums x minus 1 as multiplication by 1, by negative 1, not 1. So this way, we are going to achieve our goal. So we can do a return. We return the result. So this is a solution, I would say. Let's quickly run it. So for example 1, we get 2 and 3. So let's check for the generic case. Yeah, it passes all the cases. So I guess let's first walk through this example 1, and then we do some comments. So this is the example 1, right? Its length actually is 8, right? Length is 8. So at index 1, we have number 4, right? Then we are going to check at the 4 minus 1 at index, in other words, at index 3. This is 7, right? So it's positive. In other words, 4 hasn't not appeared before. It's not appearing before. So we mark this element at index 3 to be negative. That's the current state of nums. And then we iterate for I equals 1. So the number is 3. Then we check 3 minus 1, this index. So this index corresponding to 2, right? So it's positive. So we do is negation. And then we continue. At index 2, so we are going to check, so this is negative 2, right? So but negative 2, we see positive 2. So 2 minus 1. So we get, this is 3. At index 1 is 3. So this is a positive. Then we just do negation. And then we look at I equals 3 corresponding to negative 7. So we consider the absolute value is 7. 7 minus 1 at index 6, which is 3, right? So we are going to negate this one. So we get this current state. So now let's look at this one. I equals 4, x corresponding to 8. So then we check index 7. So it's actually a 1, still positive. Then we do negation. And then if we look at index 5, this is the first time we meet a duplicate. So because at index 5, the number is 2. So we are going to check nums 2 minus 1. So at index 1, which is negative 3, this tells us 2 has 2 appeared before, right? In other words, 2 is a duplicate. So in this case, I still do negation for index 2. So 2. So here I need to do a negation, I guess. Right. So first we add 2 in the duplicates, and then at index 1, so we do negation. So we get here is negative 3. So now it's 3. Now at index 6, so what we get is -3. So what we want to check is the absolute value, that is 3 minus 1 is 2. At index 2, this is -2. It's still negative. It means 3 appeared before. So we're going to add 3 to the duplicate, and then we negation for index 2. So we get 2 here. So at index 7, we get x equals -1. Then the positive 1, the absolute value will be positive 1. So we're going to check at index 0, so which is a 4, right? So then we just do negation. So this will be the walkthrough. So in this case, we find 2 and 3. And this is the final state of the nums list. So you can print out this final state. This is now, so we use fstring to print out that. So you can compare this one with our manual walkthrough here. They match, right? So this is one way to view this problem. So here, as I mentioned, so if you already get the duplicate, if you don't want to do negations for such cases, you can just do this, right? So then still you get the right answer, you see. But the final state of this one is different. Here we have -4, 3, 2, and here we have -4, -3, -2. So the difference is induced by this writing, right? So in other words, there are two ways you can write this. You can just do negation in the else block, right? So this is the one way. So, or you can always do negation, even after you find the duplicate, right? So our walkthrough is following this way of writing, right? But this is a small detail you need to notice. So actually, in order to get or genuinely understand the algorithm or the coding, we need to pay attention to such small details, right? So with that said, I guess that's basically about it for the current problem. You're welcome to follow up our other videos or check out our channels for more practices. If you have any comments, please let us know. Thank you for watching.